right, so let's discuss the warm-up. If a car travels a total distance over various time intervals, you can determine how fast the car was traveling using the distance formula. So what do we think D, R, and T represent in the distance formula? Hopefully all of you, go ahead, William, what do you think? Perfect. So in that formula, D represents distance, R is rate, and T is time. Question B, how many miles did the car drive in the first 3 hours? So what you would do is go over to your table, look at 3 hours, and determine that he went 204 miles. Yeah. Oh, sorry about that. That would have made B and C a little difficult, wouldn't it? And then part C, what rate was the car traveling in the first 3 hours? So if D equals RT and R is rate, to determine the rate in the first 3 hours, we could rearrange that formula to be solved for R. So we see that rate is equal to distance divided by time. So you would take the distance you got in part B, which was 204 miles, divided by the time, which was 3 hours. And the rate is 204 divided by 3, or 68 miles per hour. So hopefully they were on the highway. So today we're going to talk about rates of change and slope. These two words mean the exact same thing. So if you're asked to calculate the rate of change or you're asked to calculate the slope, you're calculating the same thing. So we've learned slope over time. Slope is the ratio of change in the y values to the ratio of change in the x values. Back in the day, you learned this to be rise over run. And we used to call it rise over run because the sun rises up. So you were counting your ups and overs. And then if a person is running, they're running along the horizon. So the rise over run came from the idea that the sun rises and a person is running. So the slope of a line is the same as its rate of change. We discussed that. Rate of change is often thought of as a change in quantity over a change in time. So again, that rate of change, it's change in a quantity over a change in time. Often we talk about rate as distance over time. Anybody still copying down the definitions? Okay. So in this first example, we have that the table shows the change in temperature of a solution being removed from heat. So if you think about something being heated, it's going to start hot and cool down after being removed from that heat. So you'll notice that the temperature is decreasing as time is increasing. Find the rate of change in the temperature for the solution. So if temperature is decreasing, that's my Y values, and time is increasing, I would assume the rate of change to be negative. So if we find the rate of change in the temperature for the solution, we could pick any 2 points and find their change. So we could do the rate of change in the temperature after 5 minutes. We could do the rate of change in the temperature after 10 minutes, and so on and so forth. If we did it after 5 minutes, we would get negative 2.1 degrees Celsius per minute. Now, if the rate of change is constant, it wouldn't matter what 2 points we picked. So I could pick any 2 points and I would get that negative 2.1 degrees. So if you tried on your own and you had picked another point, you should have gotten those exact same values. So what that means in terms of an explanation is that the temperature of the solution is decreasing 2.1 degrees Celsius every minute. The decreasing takes away the negative in your explanation. So a lot of you that just took those PSATs the other day, you might have noticed that sometimes you had to select the answer that was like the explanation to the problem. So it wasn't just finding the problem's answer, it was being able to explain it. And that's a large part of what we're going to do in this unit is explain what slopes and rates of change represent. Okay, in example number 2, we have a baseball player, and we have the baseball player's hits after 30 games and their hits after 100 games. So we're looking at the change in his average hits per game. So it's average hits per game. So we're going to put the number of hits on top over number of games. So in 100 games, he had 80 hits. And in 30 games, he had 25. So in 70 total games, he had 55 hits, or an average of 0.785 hits per game, which is very good. So in 14 games, he would have 11 hits. Okay, the equation of a line, like we previously gave our idea for, is change in quantity over change in time. It's also known as rise over run. So when we talked about the equation of slope, we didn't necessarily talk about the formula for it. So the formula is y2 minus y1 over x2 minus x1. It's y2 minus y1 over x2 minus x1. Where x1 and y1 are my given points. So using the idea for the equation of slope, let's find the slope of the lines in those next 3 examples. So using the equation for slope, we can find the slope of the line given any 2 points. So as long as we have 2 points, we can find their slope. Good. So in that first example, we have x1, y1, x2, y2. So we're going to plug into our equation for slope. So it would be y2, which is negative 6, minus y1, which is 7, over x2, which is 8, minus x1, which is negative 2. So a minus turns to a positive when you're subtracting. So it's like negative 6 minus 7 over 8 plus 2. And then the idea would be that negative 6 and negative 7 is negative 13 over 10. When we are talking about slope, we want to keep our slope as a fraction. When we're talking about slope, we want to keep our slope as a fraction. In example B, we have the slope is equal to x1, y1, x2, y2. So it's y2, which is 2, minus y1, which is negative 2, over x2 minus x1. And again, changing the minus a minus to a positive, we get 2 plus 2, which is 4, over 4 plus 2, which is 6. Now, 4 over 6 can reduce by dividing top and bottom by 2. So you can reduce your fractions, but do not change your fractions to decimals. We can reduce and simplify, but not make decimals. In example C, negative 9 minus a minus 3 over 7 minus 0. The order you write them matters. So I can't do 9 minus a minus 3 over 0 minus 7 because it will change the signs. So we get negative 6 over 7. And then in our last example, since we are not given a set of points, I need to look at that graph and identify points. So I can see that the graph of the line goes through this point right here. So the point on the graph is -6, comma 0, because it's x, comma y. And then I can also see that the graph goes through this point over here, where x is 0 and y is -3. So I identify the points on the graph, and then I just use my slope formula. So it's y2, which is -3, minus y1, which is 0, over x2, which is 0, minus x1, which is -6. So I get -3 over a +6, or a slope of -1/2. Which means my graph is going down 1 and right 2. So as we go through the lessons, we're going to start saying down 1, right 2, over 1, So instead of using the words over, we'd say down or right and left. Could also go up, but this line is going down, so it is down. Okay, you're doing the next page in the packet. It's page 79 in our book. You are doing 9 to 21. So 9, 10, and 11 are on the front, and then 12 to 21 are on the back. So you're finding the slope for a table, and you're finding the slopes of graphs, and finding the slopes with points. Yep. Hold on, I'll come look at your paper 1 second.